Hello everyone, welcome back to my channel and thank you for tuning in. In today's episode, I will show you how to set up my FrSky X20s to log and monitor the RSSI signal strength using two receivers, one being a 2.4 gigahertz and the other a 900 megahertz system. So let's get started, and if you enjoy the video, please help comment, like and subscribe on this button. Thank you for watching. So first, let's verify our setup here. Right, so here is my setup with the FrSky X20 binding to two receivers, as you can see with the RSSI status here for both bands here. And here's the 900 megahertz receiver and the 2.4 gigahertz receiver. You can ignore the spectrum receiver, it is disabled. Connection is on with, as you can see here, the service control here is working, okay, which is great. Now to verify when 2.4 gigahertz receiver is off or down, I'm just going to go to RF system and I'm going to turn off the 2.4 gigahertz here, like so, okay. Right, and then verify that the 900 megahertz is still active right now. As you can see here, the receiver, the status is green and the 2.4 is red right now. So only the 900 is active. And let's verify the service control if it's still working, and it is, with the rudder moving everything, which is great. So our system is set up with a 2.4 and a 900. In case if the whole 2.4 gigahertz band is hit, the 900 backup will be a saver for our plane. Then now the second step is to set up our radio to capture and save the log of the RSSI when we're flying. Okay, so just power up the radio and select the radio airplane icon here, scroll down and look for special function. Okay, click on that and we need to add a special function here. So let's do that. And with the action, we want to look for, here we go, write logs. We're going to capture the log and we're going to enable that. And let's set the active condition to a switch position. This switch position is when you activate it, it's going to start capturing the log of the RSSI. So I'm going to select this switch here. You can select any switch you like, but I'm going to select this SF switch here. So so I can select that. Okay, so when I turn it on, it's going to capture the log. Okay, so let's go back here, and the rest of the value, global, just leave it off, and the right interval is 250 milliseconds, and just leave a stick, switch, and everything off. So the setup is SF1 write log enable when we switch on the SF button. Okay, so we're ready to go flying right now. So here we are out in the flying field. So before you fly your plane, just make sure, I'm going to fly the ultra stick here, so I'm just going to switch this switch on, which is enable logging the RSSI value. Okay, so before I fly, I'm going to turn on that switch. So I'll start flying right now. Then now, after you complete your flight, all you need to do is just flip that switch back the other way to stop the logging of the RSSI and all its value. Now you have the log saved in your radio, so you can look post-flight at the log and analyze it. Now go into your radio, you can verify to see if the log was saved in the radio. So just hit that setup icon here and go under File Manager, and under there's a folder called Logs. Double click it, and as you can see, there are many logs here. So let's just transfer this onto the PC so we can analyze it. So in order to do that, you need to put your radio into bootloader mode by holding down these two buttons together, and just plug in the USB down here, and as usual you will mount the drive onto your PC, and you will see the mount drive pop up on the Windows PC screen. Okay, so after mounting the drive, bring up File Explorer, and you can see right here, just give it a second, it'll pop up. There's two different drives. The first is the flash drive, and the second one would pop up here is the SD card drive. You can rename this right here if you want to, so I will rename it. So under there's a log folder that we saw. So I delete some of the file already, but I'm going to copy one of the RSSI log over to another directory that I have on the PC. Okay, so now that we have the file to analyze and take a look at it. So let's analyze the RSSI log here. So open up with Excel here. Okay, so as you can see here, there's many values that capture TX battery, RX battery, but we want to look at RSSI value for 2.4 gigahertz and 900 megahertz here. So I highlight that, and let's make a chart here. So let's graph this like so. There's many ways you can graph this. I'm going to graph this like this standard here, and let's analyze this. Let's take a look here. So basically here what we have is the orange is the 900 megahertz. So first of all, it's 0 to 100. 100% is a very strong signal and 0 is a bad signal. So the orange is the 900 megahertz receiver and the blue is the 2.4 gigahertz receiver. As you can see right here, as we start flying right here, it go down as the 2.4 went down to like 40% here as the lowest point. The 900 megahertz is working in tandem with it. See, it cover even if the receiver link is weak on the 2.4, the 900 cover up simultaneously. So you're always safe with a 900 backup here, which is great, which is what you need in case of a 2.4 band all wipe out. There's a 900 megahertz band to cover you up. So what I'm trying to stress here is even if you have two receivers that is operating in 2.4 gigahertz, if the 2.4 gigahertz band is all wiped out, both of your receivers are going to get wiped out. So that's why it's good to have a 2.4 and a 900 megahertz backup. So in case of a 2.4 is wiped out, the 900 will cover you. So another thing I want to show here is another value I want to take a look at is called VFR. VFR in FrSky stands for valid frame rate. So if it's 100%, that's great. If it's 0, it's bad. So you can observe the graph of the VFR correspond to the RSSI 2.4 gigahertz for both 2.4 and 900. So let's graph that and take a look. It's another feature you can take a look after your flight to verify if your signal strength is strong enough on that day, on that flying field, on that environment that you will fly that day. As you can see here, the orange is the VFR for the 900, okay, and the gray is the VFR for the 2.4 gigahertz. And the graph is the same thing, 100 to 0. 0 is bad, 100 is good. So the VFR, as we start flying, you can see it's pretty good. But for the gray 2.4 gigahertz VFR, it went down to like 40% at some point, like right here. But still, you can see that the VFR for the 900 valid frame rate is still good. So in summarize, this logging feature on the FrSky X20 is very important. As a matter of fact, it is powerful. Why? Because you can analyze and observe the radio connection link to see if it's good or not, so that you can make your plane safe either by the need of moving the receiver and the antenna around to get better reception or avoid that flying field area environment. In all, bottom line is to save your plane from crash that can be avoidable. So that's what I want to share with you, and thank you for watching and fly safely everyone.